Permeability is a fundamental property in soil mechanics that describes how easily water can flow through soil. It's crucial for understanding groundwater movement, drainage, and stability in geotechnical engineering. First, definition. Permeability measures a soil's ability to transmit water inflows by particle size, void ratio, and saturations. Second, importance. It affects seepage, sediments, and slope stability. Poor drainage can cause waterlogging, while high permeability may lead to eruptions. Understanding permeability helps engineers design effective foundations, dams, and drainage systems. It's a small concept with a big impact on constructions and environment projects.
Let's talk about how permeability affects geotechnical structures. Permeability is a key soil property that influences water movement. When the soil has a high permeability or high K value, it allows water to drain quickly. This is ideal for structures like football fields and seawalls, where fast drainage helps prevent waterlogging and flooding. On the other hand, a low K value or low permeability is used when we want to retain water or prevent leakage. For example, clay courts in dams are designed to stop water from seeping through it, while rice paddy fields need low permeability to keep the water for crop growth. So depending on the function, we either promote or restrict water flow using different soil permeability levels.
Hi, so let's break down 3 big geotechnical challenges and their fixes. First one on the list, we have unstable slopes. In order to overcome this, engineers tend to build retaining walls, but only after analyzing soil composition. No shortcuts or landslide will happen. Next one on the list, we have uneven settlement, which will causes cracks. And the solution? Smart foundations such as raft or pilings that distribute weight even. And last on the list, we have expensive soil. For instance, clay, which will swell and shrink. Engineers either control moisture, stabilize soil, or design flexible structures. Always check for permeability, as sandy versus clay soils behave totally different near groundwater. Retaining walls, smart foundations, and soil prep are the key to avoid disasters. That's all from me, thank you.
Hi everyone, today we're taking a quick look at geotechnical tests used to measure soil permeability, both in field and in the lab. Field tests include borehole permeability tests, where water flows in or out of a borehole is measured. Second is infiltration test, where a hole is filled with water to see how fast it drains. In the lab, we use constant head test for coarse-grained soil, measuring water flow at a constant pressure, and triaxial parameters, which test soil sample under controlled stress.
Now, let's talk about seepage. Seepage is basically how water moves through soil. Kind of like water sneaking its way through tiny spaces between soil particles. It usually flows from higher ground to lower ground. Now, why does this matter? Well, if too much water seeps too quickly, it can actually wash away soil, which might weaken things like dams or building foundations. That's why engineers measure how fast the water flows through soil, so they can spot any risk early and make sure everything stays safe and stable. That's all from me. Thank you.